In this video, we'll do part 2 of our R.8 lab, solving absolute value inequalities. All right, so number 4. Remember, the first thing you have to do when you're solving absolute value inequalities is you want to isolate the absolute value bars. So I'm going to subtract 2 from both sides. I meant to have a highlighter there. Whoopsie. I'm going to subtract 2. So 5 minus 2, that's where the 3 came from. Divide both sides by 3. 3 divided by 3 is 1. So we have x, the absolute value of x minus 4 is greater than 1, greater than 1. So we're going to split up our inequality and connect the two separate inequalities with the or. Okay, so we rewrite the first inequality right here exactly like we saw it there. So just take out the absolute value bars. So x minus 4 is greater than 1. And then in your second inequality, you want to take the x minus 4 out of the absolute value bars, but then you want to change both of these signs. So -1 and the greater than sign becomes a less than sign. So less than -1. So we add 4 to both sides, and that's where the 5 comes from. 1 plus 4 is 5, so x is greater than 5. And then we add 4 over here. 4 plus -1 is 3. So x will be less than 3. All right, so we know that all the x values have to be greater than 5, or all the x values have to be less than 3. Remember, one or the other or both. So when I put this on the number line, I have my 3 open circle because it's a less than sign. So there's less than 3. And then I have 5 open circle because x is greater than 5, and I shade greater than. And remember, with an or, it's anywhere between, not between, anywhere there's shading. So from -infinity to 3, and then from 5 to infinity. Don't forget that union sign means or. So your answer is this in interval notation, parentheses, -infinity to 3, parentheses, union, parentheses, 5 to infinity. Watch your parentheses. All right, number 5. We can't just work with this inequality from the inside out like we did on the one earlier in the lab because of those absolute value bars. So I have to separate these into 2 separate inequalities. So you'll notice this side right here, -4 is less than the absolute value of 2x plus 2. That's where that came from. And then we're going to get the second inequality. We're going to look right here. So we have the absolute value of 2x plus 2 is less than 6, less than or equal to 6. So that's where that came from. So I'm going to look at each of these as 2 separate problems, and then I'm going to combine the answers together at the end. So let's start with -4 is less than the absolute value of 2x plus 2. Well, I want to switch that around. What if I wrote this as the absolute value of 2x plus 2, and notice how the inequality sign is open towards that 2x plus 2, so I need to keep that consistent. So that's saying that the absolute value of 2x plus 2, which is always a positive number, and positive numbers are always greater than -4. So for this first equation, we have all real numbers. So any x that you plug into that inequality is going to be true. It's going to give you the same thing on both sides. All right, so now let's focus on this second inequality right here. So I see that's a less than sign. So less than is and. So we actually have 2 ands here. So anyway, we're going to rewrite the first equation exactly the way we see it without the absolute value bar. So look back right here, exactly the way we see it without the absolute value bars. We have 2x plus 2 is less than or equal to 6. And then we take that same thing and we rewrite it without the absolute value bars, but we change both signs. So that less than or equal to becomes a greater than or equal to positive 6 becomes a negative 6. And then we're going to solve each of these inequalities. So I'm going to subtract 2. 6 minus 2 is that 4. Divide by 2. We get x is greater than or equal to 2. And 2x plus 2 is greater than or equal to negative 6. Subtract 2. Negative 6 minus 2 is negative 8. Divide by 2. X is greater than or equal to negative 4. So then I came over here and I shaded all three of these. So the shading for the real numbers was in black. So the one that has the always any x will work is going to be that black line. And then I put a closed circle on negative 4, and it says x is greater than negative 4. So I did that in orange. Let me put this where you can see it better. X is greater than or equal to negative 4. So that's this way. And then x is less than or equal to 2 is this way. And then, of course, the black line goes forever. So where all three are shaded are going to be right here. Because remember, and we want this overlap of our shaded region. So they're all three shaded between negative 4 and 2. But notice those two points at negative 4 and at negative 2 are closed circles. We have the less than or equal to sign there. So our answer is from negative 4 to 2, surrounded by brackets, not parentheses. All right, number 6, subtract 3 from both sides, and we get 1 minus 3 is that negative 2. Divide both sides by 2, we get negative 1 on that side. But then I want you to think about this. Your absolute value of any number, since it's the distance away from 0, is always positive. And positive numbers are never less than negative numbers. So we have no solution here. We could also write this as our empty set. All right, then number 7. We're going to start by subtracting 2 from both sides because of that plus 2. So we're going to do a minus 2. So 5 minus 2 gives me that 3. Then we're going to divide both sides by 3. 3 divided by 3 is 1. Now remember, we are isolating the absolute value bars. So I have to get everything away from the absolute value bars. And then I see that less than signed. So when I see less than, I know this is going to be an and situation. So I rewrite the first inequality exactly the way the absolute value inequality was written, but just get rid of the absolute value bars. And then I take out the absolute value bars and just write down what's inside the absolute value bars. So x minus 4. And then I change both of these signs. So less than or equal to becomes greater than or equal to. Positive 1 becomes negative 1. Clean up some of this. All right, so then solving both inequalities, we have x minus 4 is less than 1, so I add 4. We get x is less than or equal to 5. And then second inequality, we're going to add 4 again, so negative 1 plus 4 is 3. So we get x is less than or equal to 3. So over here on my number line, we have x is greater than 5. That's this way. And x is, I lied. I hope y'all are yelling at me. X is less than 5, so it's going to be this way. And x is greater than or equal to 3, so it's going to be this way. Well, here is where they're both shaded. So and is the overlap or the intersection. So all of the solutions to this inequality lie between 3 and 5, including 3 and 5. That's why we have the brackets in our interval notation.